Okay, so a short little video to show you how to use the Chart That Motion Interactive on the physics classroom. So there are 12 bar charts to match to a verbal description. You can match the bar charts in any order. Once you're successful at matching a bar chart, a gold star will appear to the left of the button. We're going to go ahead and try a couple of these things here and just show you how the simulation works. My hope is that you'll finish up all 12 of these things, get a gold star next to all of them. So I'm going to choose a couple of these things at random. Let's start with bar chart 11. So use the lettered buttons to select a description that matches the bar chart shown below. When you think you have a match, tap the check answer button. So down here we have two different bar charts to show you the initial energy state and the final energy state. Your goal is you have to select one of these things up here, A through L, that would give you a description that sort of matches this. So let's see. The initial state of energy is potential energy, and then the final state of energy is kinetic energy. So it could be something like our egg drop device, as an example, where the egg drop started at the top of the balcony. It had gravitational potential energy, sort of mgh there. And then as it dropped, the Earth exerted a conservative force of gravity to convert that potential energy into kinetic. Okay, so something along those lines. Now I'd click up here on these and see if any of these descriptions sort of match that. This is a car moving along a level roadway at a constant speed. That doesn't seem to match. Driver steps on the gas of the car, accelerates from rest. Okay, that doesn't seem to match this one either. The driver hits the brakes of the cars and slows down. Well, any kind of thing like hitting the brakes would be a non-conservative work done by non-conservative forces. That's not going to be it. Golf ball encounters some resistance. Again, that would be a non-conservative force. Let's see, a baseball player hits the infield dirt, slides to a stop. Again, those are all non-conservative. Ski lifts the riders up. Well, that requires work by external force. That's not going to be it. The ball is moving upward. That could be it, except it's moving upward, which would mean an increase in potential energy, not a decrease. That's not it. Skydiver falls at constant speed. If it's constant speed, we know there has to be air resistance there. Girl on a sled starts from rest and slides from the top of a hill to the bottom of the hill. There we go. It's sort of like our egg drop device. Starts with potential energy and allows the Earth to do work on her, converting that potential energy into kinetic. That would be it. And when I check that, congratulations, it looks good. Let's do one more here. Bar chart number 2. Let's see, potential energy is what we're starting with. It looks like there's some work done by external forces to that would tend to increase the energy of the system. And so we can see over here we had 4 units. Now we have 4 and 2, we have 6. So that makes sense. We have a certain amount of energy to begin with. We're adding some energy to it. So when we're all done, we have 4 plus 2, that's 6. I can see that those 6 now are in the form of PE and KE. My goal here is to try to find a situation up here that matches that. Let's try this one here. Girl, that's the one that we did before. Girls, that's not it. Starting from rest, a car accelerates from the bottom of a hill to the top. Well, that would be an increase in PE. That's not it. Let's try K. Starting from rest, a marble rolls down a ramp. Again, the idea that could be it rolls down a ramp, so the decrease in potential energy collides with a folded note car. If it stopped, it wouldn't have kinetic energy. That can't be it. Let's try L. A stationary cross-country skier uses her poles to help propel her. That'd be work that she's doing to increase her speed. She's going down a hill, so the potential energy would be less, and she's speeding up as she goes. So that looks like it could be right. Let's go ahead and check that. And sure enough, that's it. Now, those two things that I did there were to help you see how you might use the interactive. These are not going to be in the same order for you, but go ahead and try all 12 of those, see if you can get through them. Persist. This can be a challenging interactive, so see what you can do with it. Good luck.